Hello once again. Let's go ahead and do exercise 10.2. Now, I'm just looking over some of these problems. Some of these problems have like 8-9 different questions or small questions like this one. I might just do a couple, and then hopefully that kind of gives you an idea of what this is all about. Let's start with, I might just kind of do a couple of these, okay? I might kind of bounce around a little bit. Let's do A first, okay? Without using a calculator, determine the following trigonometric ratios, whether they're positive or negative. That's all it's asking. So sine 230, remind yourself, what we learned in this video was everything's positive there. Sine is the only thing positive here. Tan is the only thing positive there. And cosine is the only thing positive there. So, sine 230 would end up being in Q3. That ratio, okay, that ratio is going to be negative because tan is the only thing positive there, right? Let's do maybe one more. How about we do like something like H? So for H, I have tan negative 155. So I'm going in the opposite direction, this way. So there's where my trigonometric ratio is going to be. You just have to find out whether this is positive or negative. Again, remind yourself, everything sine, tan, and then cosine. But we did mention that tan negative 155. So, and we are dealing with a values that have opposite over adjacent. So this should be positive. So this should be positive here, since we're dealing with 10, and 10 is positive in Q3. Okay. Again, I'll do maybe one of these just to kind of give you the idea. Let's just do 2D. It tells you sine and tan have opposite signs. So which quadrants would this apply to? Okay, where sine and tan have opposite signs. Again, remind yourself, it's always a good idea to put this down. That way we can kind of go one piece after the other. Now, sine and tan have opposite signs, so one has to be positive, the other one has to be negative, okay, or vice versa. Well, does that apply to Q1? Well, no, it's not going to apply to Q1, because they're both going to be positive there. Let's look at sine. Let's look at quadrant 2. Well, sine's going to be positive there, tan's actually going to be negative there, so actually it is Q2 that we can say that this works out to be. Okay. Let's go to Q3. Well, tan is positive here. Sine is going to be negative there, so it actually applies to Q3 as well. So Q3 also applies to this as well. How about Q4? Cosine is the only thing positive there, which means sine and tan would both be negative, so it's not going to be Q4. So that kind of gives you an idea of what 2 is all about. So I just did 2D. Alright, number 3. Number 3, evaluate the following. Okay, I'm going to do one of these the way we traditionally do it, and one of these with obviously your unit circle, right, which we learned in the video. Now when you deal with 10, remember, I'm not actually going to use a unit circle here because it's not that complicated, but all you need to know for 10 is it's equal to sine over cosine. It's an identity we'll kind of learn later. But that's basically how you can do 10 here. So look, if you take a look at 300, which is right there, you would do sine, which is right here, over cosine, which is right there, and you'd simply get what what the ratio for tan 300 should be. Okay. Now, you're going to have to divide fractions there, which some of you are not comfortable with. But again, if you need to, then that is an option for you. Okay. I will do it the way we've traditionally done it. So I'll go ahead and say, well, tan 300, it goes around the circle 300 degrees, which means it gets left with a base angle of 60. Okay, so this should be a 30, 60, 90 triangle. I know my ratios, which are 1, square root of 3, and then 2. Remind yourself which one should be negative. I know this should be a positive one, but this should be a negative square root of 3. Okay? So tan 300, that's opposite over adjacent. I know 60 is my reference angle. Opposite is right here. Adjacent is right there. So for tan 300, I have the answer of square root of 3. Sorry, negative square root of 3. Okay? Which would, again, if you did your unit circle, that's basically what you would find out. Sine over cosine. Let's do letter B. Okay, so for letter B, we can actually use the unit circle. Again, if you have it memorized, it's pretty easy. Cosine 330, so I'm looking right here. Cosine is right here. Sine is right there. So I know cosine 330, again, no work involved really, would be equal to square root of 3 over 2. Okay? It's just easy, as easy as that. Let's go ahead and do one more. Maybe something like that, right? Where it has a negative value. Actually, maybe if we do, okay, well, let's do G and H, both of them. Let's do G first. G, I know I have negative 120. I'm going in this direction. It will have a reference angle of 60. This is 30, and this is, of course, my 90. Let's go ahead and put our ratios. That's square root of 3. This is 2, and this is 1. I know that this is going to be negative 1. I know this is going to be a negative square root of 3. Because, again, it's going on the left of the x-axis, and it's going down on the y-axis. They both have to be negative. Again, if you need to, go ahead and remind yourself of what's positive, what's negative. So for tan negative 120, I know it's going to be positive because it's tan. It's also in Q3, so it's definitely going to be positive. I know it's going to be opposite over adjacent. Opposite, which is right here. Adjacent, which is right here. Negative over negative ends up being a positive. So the value for G is just square root of 3. Okay. Let's go ahead and do H. Again, I can't do all these because it'll just take me all day. But just so you can get a sense of what's going on here. H. Sine 405. We're going to have to go more than one revolution. 90, 180, 270, 360, and then I'm basically going to have an angle of 45, right? I should have an angle of 45 since it went past 360. So 45. This should also be 45, and this is my 90. And again, if I know that this is going to be a 45, 45, 90 triangle, okay, what I can do simply is just work off of the unit circle, okay? So the unit circle for sine tells you that this should be square root of 2 over 2. So again, your unit circle comes in very handy. This is what your answer for H should be, okay, just based off of your unit circle. Alright, number 4, I've got your theta. Your angle is going to be acute, and it's going to have the function of cos for 4 over 5. Find the value of sine and tan. Okay. Alright, so let's go ahead and make our model. We know it's going to be acute, so it's going to be from 0 to 90 degrees, or less than 90 degrees. And that doesn't really matter how so here's my acute angle, right there. We know we have to label that theta. Okay. Adjacent over hypotenuse. I know my sides are 5. I know my adjacent side is 4. And of course, I'll end up finding that this is going to be 3. I'll have to do Pythagorean theorem. Find the value of sine, theta, and tan. I know cosine already. That's 4 over 5. Sine is going to end up being, again, use this as your reference angle, opposite over hypotenuse, that's 3 over 5. And then tan is going to be opposite over adjacent, which means 3 over 4. And again, all these values are going to be positive. Why? Well, because everything's positive here in Q1. Okay, so here are your 3 answers. 5. Given that 8 is obtuse. Okay, well, obtuse means from 0 to less than 180. Okay? Greater than 0, but less than 180. I know it's going to be in Q2. Okay? It's an obtuse angle. So I know it's going to be Q2. Right? This angle is going to go from here to here. Basically what I need is my base angle, which is in this case called A. This is my right angle. Okay? Let's go ahead and put our values in. I know this is going to be opposite over adjacent. So, again, using my reference angle, I have opposite, which is right here. My adjacent side, which is right here. And then again, once I do Pythagorean theorem, this should be square root of 5. A couple things to remember. This should be a positive 1. This is actually a negative 2. Okay? Because it's going on the left-hand side of your x-axis. Alright, so let's figure out cos and sine. Okay, we know what tan is. Tan is equal to negative 1/2, which makes sense. It is where sine should be the only thing positive. Speaking of sine, let's go ahead and find what sine is. We know it's going to be positive already. Opposite over hypotenuse, which is 1 over square root of 5. Okay, that will end up being square root of 5 over 5 once you rationalize. Okay, cosine adjacent over hypotenuse ends up being negative 2 over square root of 5. Okay, don't leave it like this. I'll have to multiply by square root of 5, square root of 5. I end up having negative 2 square root of 5 over 5, so that should be your answer right there. Here's sine, and here's tan. Numero 6. Okay, so number 6 says, given that sine A is negative 5 over 13, it's going to be in this quadrant, which basically is Q3. It's between 180 and 270. It's going to be in Q3. Find the value of tan, and then find the value of cosine. I'm going to find this out first. Okay, it has the value. Let's go ahead and make our model. This is A. Let's go ahead and put the following sides. I know this is opposite over hypotenuse. Opposite being 5, hypotenuse being 13. Eventually, you will find out that this is 12. Okay. Now let's fix a couple things. This actually should be a negative 12, and this actually should be a negative 5. Reason being is because it's going left on the x-axis, that's negative. It's going down on the y-axis, that's also negative. And so we already know what sine is. It's asking us 10. So for 10, that's opposite over adjacent, which means 5 over 12. Or negative 5 over negative 12, which is just 5 over 12. So that's your first answer. Now cosine negative a. Okay, so here's the thing about that. That's going in the negative direction. This went in the positive direction like this. Well, now it's going to go in the negative direction. So if I went in the negative direction, instead of going where the yellow is, it's going to go in the opposite direction, but the same measurement. So it's actually going to land somewhere in Q2. Okay, just so I don't just so I don't get a bit messy, I'm going to recreate this. I know it's going to go in the other direction now, the negative direction. So I'm going to go the same amount, but now in the negative direction. So this is a base angle of negative a. I know the following. It's going to have the same values, right? Instead of a negative 5, it's also going to have a positive 5. This is still going to be a negative 12, and this is going to be a, either way, positive 13. So if I'm trying to figure out cos of negative a should be, well, here's my base angle. Adjacent over hypotenuse, that would be negative 12. Hypotenuse is 13, so here's what cos negative a is equivalent to. Okay, number 7. Sine is equal to 2 over square root of 5. It's between 90 and 180, so that means Q2. Find cos in 10. So I have this in Q2. I know I have my base angle of A. Okay. I know I have opposite over hypotenuse, which means that this is square root of 5. And hypotenuse, sorry, my bad. Alright, that should be square root of 5. And opposite should be 2. When you do Pythagorean theorem, you should get a value of 1. Okay. Now let's fix a couple things. This actually should be a negative 1. Again, it's going on the left side of the x-axis. 2 is fine, square root of 5 is fine as well. Let's go ahead and find what cos is now. And let's go ahead and find what tan A is now. Cos is going to have the value of adjacent over hypotenuse, which means that is going to be a negative 1 over square root of 5. Okay. But again, I have to rationalize that, so you should end up with a negative square root of 5 over 5. Tan is opposite over adjacent, which means 2 over negative 1. Of course, that's just negative 2. Okay, so there's cos and tan. Alright, number 8. Number 8, we have cosine being 1/2. We do know cosine and sine have the same sign. The fact that cosine is positive here, because there could be a couple things that it could be positive in Q1. It also could be positive in Q3. Okay, but we're not going to choose Q3 because cosine A is equal to a positive value. Okay, I know I'm going to have a reference angle of A. Opposite side would be square root of 3. So that would be a square root of 3. Adjacent side is 1, and this would be 2. I'm going to say, again, it says find the value of 10a. We're going to do this second, okay, because that's going to be a negative theta. So 10a, well, 10a is not too bad to get. Opposite over adjacent, that would mean that would be square root of 3. Okay? Now, sine negative a. Let's do that on this side. Sine negative a, remember how this positive a worked out. It went not so far, but again, that went in a positive direction in Q1. This time, it's going to go in a negative direction the other way. Okay? So now, I have the negative theta here. Okay? And again, if you're looking for you basically have the same ratios, just on the other side. You have square root of 3. Sorry, that's not square root of 3. That's 2. So 2. I have square root of 3, and then 1. Okay, remind yourself, this actually should be a negative now, because it goes down on your y-axis. So if you're asking what sine negative a is, that will be, again, opposite over hypotenuse. That's negative square root of 3 over 2. Okay. Number 9. 10a is negative 5 over 12. Let's go ahead and make our graph. I know 10a and cosine a have opposite signs. Okay. Where they have opposite signs, again, with 10 being negative, that would have to be in Q4. Let's go ahead and make our sides. That's opposite over adjacent. So 5 and 12. This will end up being, my hypotenuse will end up being 13. I know this is going to be a negative 5, so make sure you, because it's going down on your y-axis. Okay. It does ask us cosine 90 minus a, but let's find out what cosine a is first. Find the value of cosine a. That will end up being adjacent over hypotenuse, which is 12 over 13. Cosine 90 minus a. Okay. So cosine 90 minus a is right here, because again, your triangle has to equal 180 degrees. Cosine 90 minus a is negative 5 over 13. Remember, cosine 90 minus a is the same thing as sine. Okay, one of those identities you have to remember. So here are your two of your answers for number 9. Okay, for number 10, I'm just going to do one of these since I just kind of want to save time. Let's go ahead and do, let's see, we can do number 10b. Okay, let's go ahead and do 10b. Okay, cosine is equal to square root 2 over 3. I would encourage you guys, okay, to, instead of saying cosine a is equal to square root 2 over 3, I would suggest you to do this, because they mean the same thing. I would just break it apart. Okay? That way, you do know what A is, and what also H is as well. Okay? So, with that being said, okay, let's go ahead and put our values in. Okay? It does mention it's between 180 and 360, so forget Q1 and Q2. It's got to be either in Q3 or Q4. And then you ask yourself, well, which one is it? Is it Q3 or Q4? Well, this will tell you that this is in Q4 because cosine's positive. Okay, well, I'm going to go ahead and recreate my right triangle. I now have a reference angle of A. Okay, and I know that my adjacent side is square root of 2. So square root of 2. I know my hypotenuse is square root of 3. Okay, and when I do Pythagorean theorem, I know that this value is 1, or in this case, negative 1. Okay, because it's going down on your y-axis. Alright, so let's say what sine 90 minus a actually is. So sine 90 minus a, again, remind yourself of a couple things. This should be 90 minus a. So sine 90 minus a is equal to opposite over hypotenuse. Okay, sine 90 minus a is also equal to your cosine. So this would end up being square root of 2 over square root of 3. Okay, obviously you can rationalize that. Once you rationalize that, you should end up with square root of 6 over 3. Okay, so this should be your answer for B. Okay, number 12. I'm not gonna do all these. I'm just gonna do a couple of these so you can get a good gist of what's going on here. We haven't done a lot of these, okay? But let me give you a bit of an overview of what this is all about. So, for instance, let's just do A together. A says cosine of x is equal to negative 0.71. Okay. Now, over here, what we have here is the function or the ratio of cosine, right? Remember, cosine is just a over h, and the value of a over h is this, just negative 0.71. Okay? What I'm asking you is you to find the angles associated with this ratio from 0 to 360. Okay? So you're going to have to use a calculator because there's no way, these are not special right triangles, right? You can't really decipher these based upon what I've given you here. Okay? So with that being said, again, you're finding the angle associated with the function, okay, or the ratio. So the first thing you have to ask yourself is your cosine, like, is this by itself? Okay, if it's not by itself, you need to make sure it's by itself first. Okay, in this case, it's by itself. Okay, now, since it's by itself, in your calculator, okay, make sure it's in your calculator's in degree mode. You want to click Shift, right? You want to do Shift, and then you want to go to cosine, and something like this will pop up on your calculator. So now within those parentheses, you want to put exactly what your function is, or your ratio is, and you will end up getting 135.2. So, and that's in degrees. Okay, that's only one of your answers. Okay, and that's one answer, but you need to again ask yourself, remind yourself, well, where's cosine negative? Right? It's negative in two places. Cosine is negative in, well, it's not here. It's going to be negative here, right? And it's also going to be negative here. That function is going to be in Q2. It's also going to be in Q3. Okay? So, I know I'm going to have one in Q2 and one in Q3. Now you have to ask yourself, again, what angle did I get? I got the angle of 135.2. Well, the same base angle is going to be in Q2 and also in Q3. So you need to find that base angle. So 135.2, that has a base angle of 44.8. So again, this is going to have the value of 44.8. Again, that's a base angle, not the theta, but the base angle. Well, if this is 44.8, the other base angle is also going to be 44.8. Okay, so I have two angles that are associated with this ratio. Okay, one's in Q2, one's in Q3. So the first angle I already have, right? My calculator gave me that. That's 135.2. I need to find where this angle is right here. Again, this angle right here. Right? That's 180 plus 44.8, which ends up being 224.8 degrees. Okay, so here are both your answers. Okay. Now let's do at least a couple more. Let's skip B. Let's skip C. Let's skip D as well, because they're all about the same. Let's go ahead and do E. Okay, so that is 10 cos x minus 3 is equal to 0. Again, your trig function has to be by itself. Okay, so plus 3, and then eventually I'm going to divide by 9. Or sorry, 10. So cos x minus, I have 10 cos is equal to 3. Let's go ahead and divide by 10. Divide by 10. I end up having cos x is equal to 3 over 10. Okay? Now, we're going to do this exact same thing. I'm going to go a bit quicker now. So I know cos x is equal to 3 over 10. Okay? Ask yourself, well, where is cos positive? Okay? Cos is going to be positive here. Right? It's also going to be positive here. So I know my two angles are going to be right there. You want to find the angle associated with this. So you want to do cos -1 of 3 over 10 in your calculator. And you'll end up getting the value, what do you get? So shift cos, you get the value of 72.54. 72.54. Okay, again, that's also your base angle as well. So 72.54. Again, that's your base angle. You're always going to have a base angle and theta the same in Q1. Okay, you know that's also the base angle in Q4. Okay, so to find the second angle, all you want to do is 360 minus 72.4, and you should end up with 287.46. Okay, so those are the values that you should get for E. Alright, let's do maybe one more. Let's do F. Okay, I think F would maybe give you some of you guys problems since you have two tan functions. Okay, for F, the most important, since you have two tan functions there, the most important thing you can do is replace tan x with something else. Okay, so I'm doing F now. So 4 tan x minus 1 is equal to 3 times 5 minus 2 tan x. Alright. Guys, I would replace tan x with something else. Okay? So you can use a substitution here. Let's make u equal to tan x. Again, but it could be anything. I'm just making u equal to tan x. That way, at the end, we're just using substitution as a method to solve for this. So I'm going to replace tan x with u. But again, that could be x, that could be z, that could be anything. Just so we have an easier time solving for this. So tan x, sorry, but you gotta go. And I'm replacing it with u, okay, and u here. Okay, let's go ahead and simplify. Okay, now when I simplify, you end up with 4u minus 4 is equal to 15 minus 10u. Eventually, you get 10u is equal to 19, and u ends up being 19 over 10. Okay, well, what was u? Let's trace back. U is also 10x. So I know 10x is also equal to 19 over 10. Okay, I'm just replacing it with 10x. Okay. Now, now we can go ahead and get started and find the angle associated with that. So again, I have 10x is equal to 19 over 10. So when I do shift 10, again that's 10, it's going to pop up in your calculator as 10 inverse 10, or 10 negative 1. I have the base angle of just the theta of 62.2. Okay. Now where is tan positive? Again, this is positive, so I know tan has to be positive in Q1. Also in Q3. Okay. Again, I know this is 62.2. I also know this is 62.2 as well. Okay. I already have one angle. Let's go ahead and find the other angle, right? What is this angle right here? That angle right there. Okay? That angle right there, again, you can add 180 plus 62.2. You end up getting 242.2. So those are your two answers. Right? I'm not going to do the rest of these, but surely you can look up the answers online, or you can obviously ask me if they don't make sense when you look at the answer key. Okay?